In this video, we're going to have a look at how we can perform calculations that calculate the area of a circle. So looking at example A here, we've got a full circle with a radius of 5 millimeters. Radius being the line that goes from the outer edge all the way to the center. Now, if we recall back to year 8, we might remember that the area of the circle is defined as pi r squared, where r refers to the radius and pi is a special mathematical constant that equals roughly 3.141. So using this information here, if we wanted to calculate the area of this yellow circle, then what we could write is area equals pi times 5 squared, because 5 is our radius, and then it's going to be pi 25, and therefore the area of our circle is simply equal to 25 pi millimeters squared. Now, if we want to go one little bit better and say we want to evaluate an approximate answer, then what we can do is we can get our calculator and we can go 25 times then shift pi, and therefore we have roughly 78.54 millimeters squared. So alright, 78.54 millimeters squared, like so. So this is roughly our answer here. Now moving on to the second and third examples, notice that we've got something a little bit different. Notice that we don't have a full circle, but rather we've only got a portion of a circle. So this makes things a little bit trickier. So going on in the spirit of what we've done in the first one, we're still going to use our area formula, like so. That's going to be pi r squared, but it's going to be a little bit different in that we're no longer dealing with, say, the full circle, but rather we're dealing with a portion of the circle. So what we have to do is we have to account for the part that we're missing. So the way in which we can do that, we've got this measurement here of 70 degrees. What we're going to do is we're going to say that we're taking a ratio of the circle. So usually a circle itself, it has 360 degrees in it. In this case, we're going to say 360, like so. So 70 degrees divided by 360 degrees. And this is going to tell us how much of the circle we actually have remaining. So if we want to get a more general form, then what we can write is 360 and then theta on top, where theta refers to this guy here. Awesome. So doing this particular example, what we're going to get is 70 over 360 pi and then 3 squared, like so. Then evaluating this expression, we have to figure out what 70 over 360 is. So I'm going to go 70 divided by 360, and that's roughly 0.19. So 0.19 times pi times 9. Alright, 0.19 times 9 is 1.75. Pi. So the area of this smaller section of the circle is 1.75 pi kilometers squared, because the units in this case are kilometers. Now again, if we wanted to go a little bit better and get a rough estimation without using pi, then what we can do is we can go shift pi times 1.75, and that's going to come out as 5.497, so 5.50 kilometers squared. Awesome. Now, final example, over in part C, we've got a portion of a circle once again, but notice the circle itself, the angle denoted here is actually the outer part of the circle. So it's not telling us what we have, but rather what we don't have. So once again, we're going to use our formula of area equals theta over 360 pi r squared. And in this case, our definition of theta is going to be, well, if there are 360 degrees within a circle, then what is left here, our theta in here, must be something, take this guy. So 360 take that. So therefore, what we can write is we'll do one line down so it's a little bit clearer. We'll go 360, and then it's going to be 360 take 65 pi, and then 8 meters squared, like so. Alright, cool. Now putting it in our calculator, we're going to have 360 take 65, that's 295 divided by 360, so 0.81 or 0.82 if we round up. So we're going to get rid of this, 0.82 pi times 64. Alright, cool. Now simplifying that out, times the 64, it's going to be 52.44. 52.44 pi, and then the units are meters squared. Alright, awesome. And once again, if we want to write it as a number not in terms of pi, then we can go times shift pi, and therefore 164.76 meters squared. So this video has shown us firstly how to calculate the area of a regular circle. Then it's shown us how to calculate the area of part of a circle given where we're told the angle of the solid part of the circle. And then we've got how to calculate the area of a circle where the defined angle is the missing part of the circle, like so.